So we're going to do 5.1 graphing quadratic functions today, and this is something that we're going to do in two different forms. So the first thing I want to do is just focus on the actual answers of finding the vertex and everything that you see off to the left just by giving the graph, and then we'll do it with an equation. So first thing, remember that a quadratic equation, its graph is called a parabola, not a parabola, a parabola. So running through this, for number one, your vertex, remember that's a point, so that's your xy coordinate at where it changes from increasing and decreasing. So it's going to be your maximum or minimum point. In this case, your vertex would be 4, 2. Obviously, from looking from the graph, this is something that opens down, right? It looks like an upside down U instead of a right side up one. So if it's upside down, that means it opens down. Your axis of symmetry goes through your vertex. Remember, it cuts it in half, hence symmetry, right? So that's always going to be a number, and that number is going to match whatever is in your vertex. Your y-intercept, you can do this multiple ways, but for this one, we have to look just at the graph. It obviously goes through, oh, sorry, that was really thick. It goes through 0, -6. So that's going to be our y-intercept. Zeros, remember, these are talking about your x values, okay, where it crosses the x-axis, right? So it crosses at those 2 points, which are 2, 0 and 6, 0. Like I stated before, it's either going to be a maximum or min. Your vertex is your highest point, which means that this is a maximum. Reminder on domain and range. Domain is talking about your x values. Range is talking about your y's. So domain, if you think about your x's, there's always going to be every single x accounted for, because eventually it'll go all the way to the left and all the way to the right. So that's from -infinity to infinity. And then you have your range. So we think lowest to highest, right? Well, if this opens down, that means it's going to go on forever in the bottom of it, right? Which means that that's -infinity. And if we follow it all the way, the highest y value ends up being 2. And this is always going to match whatever this is. Then increasing and decreasing, these are talking about your x values always. So if you notice, the only thing that talks about your y is your range. Everything else really depends on your x's, other than obviously your y-intercept. So for increasing and decreasing, we're looking at the function. Make sure you're reading from left to right. Okay, so from left all the way to the line, that graph is increasing, right? So that means from -infinity to your x value, which is 4, you're increasing. And then from that 4 to infinity, you are decreasing. Okay, one thing I want to reiterate, I marked it, but it's not as clear as it can be. Okay, this is a bracket with 2, and that's going to be the only time that you're going to see brackets in these are with the range, because that means it's included, right? Remember, included is a bracket, not included or excluded is a parentheses. So on everything else, obviously, points are all parentheses. Increasing, decreasing is always parentheses. And we'll talk more about why later. Okay, so let's get into our first form, which is vertex form. This is the easier of the two because it literally gives you the vertex. Vertex is always h comma k. Okay, opposite of the inside with the parentheses, same as the outside. Okay, after you do that, you determine whether it's open up or down. If it's positive, it opens up. If it's negative, it opens down. And then we graph the rest of it by doing our a times 135. I write it this way. That was, sorry, a times 135. Okay, and then I write whatever it is. And you'll see that in a second. So, looking at number 2, we can pull out our vertex here, which is -1, 2. And let's go ahead and graph that. Then I know that it's going to open down based off of our a value being negative. Okay, and I'm going to continue graphing this. If a is -2, we have 135. So in reality, we're not moving 135, we're moving -2, -6, negative. So over 1 down 2, over 1 down 6, And then if we go down 10, that would be way off the graph, so I'm not going to graph that one. And we just repeat it on the other side. Our axis of symmetry, remember, is always x equals your x value in your vertex. It cuts it in half here. Your y-intercept is where it crosses the x-axis. There's another way to find your y-intercept, which is where x equals 0. Sometimes your y-intercept is going to be off the graph, and in that case, you do have to plug in 0 for x. So we would look at our function, f of 0, and plug in 0. And if we use order of operations, we would end up getting f of 0 equals 0, hence 0, 0. Okay, our zeros, remember, those are your x values. Those are the points where it crosses the x-axis. We have negative 2, 0, and 0, 0 as our zeros. This is down, so that means that this is going to be a maximum again. Our vertex is the highest point. Domain for all of these is always going to be negative to positive infinity because all x values are going to be included. Our lowest y value would be negative infinity, and our highest would end up being our 2. And remember, that's a bracket because it's included. Then we have increasing and decreasing. Remember, these are always x values, always, right? So we use our axis of symmetry to cut it in half. So on the reading it from left to right, the first part is going up, that's increasing. So from all the way to the left, which is negative infinity, all the way to negative 1, it is increasing. And then from the negative 1 to positive infinity, it's decreasing. The last thing they wanted to do is have you find f of 1. So you have two options. You can plug it in just like this and use order of operations, or you can look at the graph. Okay, if you go to where x is 1, which would be down here, right? Your y value at 1 is 6. Okay, but again, you could have done order of operations. You would get negative 2 times 2 squared plus 2, a whole bunch of 2's here. Negative 2 times 4 plus 2. Oh, this is a negative 6. So we would get negative 8 plus 2, which is negative 6. All right, so let's talk about standard form then. With standard form, it's a little different. We have to do a little bit more work. Okay? We have to do opposite of b over 2a to find out what your x value is. Notice that a, b, and c comes from your equation in standard form. It's always ax squared plus bx plus c. The next part looks a lot more difficult than what it actually is. Okay, you find your x value by negative b over 2a. You find your y by just plugging it in. So f of negative b over 2a, which is f of whatever your x value is. Same rules apply for a and it being positive, negative, and moving 1, 3, 5. All right, so let's get started. The first thing we have to do is opposite of b over 2a. So b is negative 2, so we're going to take a positive 2. And then always over 2 times a, which is negative 1. So we have 2 over negative 2, which is negative 1. That means our vertex is at negative 1 something. That also means that our axis of symmetry is at x equals negative 1. Another thing we can do without doing any other math is knowing that it's going to open down again because our a value is negative. From here, let's go ahead and find our y value. And we do that by plugging in negative 1 to our equation. So we have negative 1 as our a times negative 1 squared minus 2 times negative 1 plus 8. Negative 1 squared is 1, but then you still have the negative 1. That ends up being plus 2 plus 8. That gives us f of negative 1 equals 9. Okay, so that means that's our y value. And we could plot that point, negative 1, 9. I'm going to go ahead and graph it. I always find it easier to graph now. You don't have to at this point. You can answer more before you graph it. But we take a times 1, 3, 5, which would mean negative 1, negative 3, negative 5. So over 1, down 1, over 1, down 3, over 1, down 5. So we have 1, 3, 5. And here's our graph. Now that we have that, we can answer a lot of questions. First off, our y-intercept. Again, we can see it. We know that it's 0, 8. Okay, but we might have to one day plug in f of 0, so plug it in and then find it. Right? Another thing that's nice with standard form, whatever your c value is always your y-intercept. Okay, but that only works with standard form, so be careful because a lot of students get confused because if you go here, people think that 2 is your y-intercept, which it's not. We notice our y-intercept is 0, 0. Okay, and that's just because this is not in standard form. So be careful with that. All right, our zeros we can see from the graph are negative 4, 0 and 2, 0 because it's where it crosses the x-axis. Again, this is a maximum because our vertex is the highest point. Domain is always negative to positive infinity. Our range, our lowest value would be negative infinity because it keeps going on forever in that direction. And our highest is 9. Remember, this is the only one with a bracket. Increasing and decreasing our x values, so we're cutting it at the negative 1. So the left of it is increasing, so that's negative infinity all the way to the negative 1. And that means the right would be decreasing, which is negative 1 to infinity. At this point, I encourage you to try this one on your own before you watch me do it. So go ahead and pause the video and try it, and then keep the video going after that to check your work. Okay, so at this time, hopefully you had enough time to get done with this problem. So first thing you have to do is opposite of b over 2a, which gives me 6 over 2 times 3, which is really 6 over 6, which is 1. That means my vertex is 1 and my axis of symmetry is x equals 1. This one was different. It opens up because a is positive. To find your y value, you plug in 1. So f of 1 equals 3 times 1 squared minus 6 times 1 plus 4, which is 3 minus 6 plus 4, which gives 1. We can go ahead and keep graphing this now. Our a value is 3, so we multiply it by 135. We get 3, 9, 15. So over 1 up 3. And then if I go up 9, we go off the graph, I'm going to leave it like this. So our y-intercept is 0, 4. And we can see that from the graph. We can also see it from our equation because we have the plus 4 at the end. Okay, but remember that only works for standard form. 0, hopefully we didn't get picked on this one. Okay, the zeros doesn't cross the x-axis, so I'm sure some of you know solution. The absolute correct answer for this would be no real solutions. This would also be a minimum, not a max, because our vertex is the lowest. Domain, negative to positive infinity. Range this time is a little different because our lowest is now our 1. It's the lowest y value. And our highest is infinity. So hopefully we didn't get tricked there. Last step is our increasing and decreasing. So it is, again, cut in half with the axis of symmetry. On the left, if you read it from left to right, it is decreasing this time. So from negative infinity to 1, it's decreasing. And then 1 to infinity, it's increasing.